A linear equation has degree 1. Degree of linear equation is 1. Okay. General form of pair of linear equations in two variables is, so pair of linear equations means we are talking about two linear equations. Two variables are two. That means first linear equation will be a1x b1y plus c1 is equal to 0. This is the first linear equation in two variables. What are the variables here? X and y are the variables. Next linear equation will be a2x plus b2y plus c2 is equal to 0. This is the general form of pair of linear equations in two variables. Got it? So these are two linear equations. That's why we are calling them as pair of linear equations. Degree is 1. Degree of these equations is 1. That's why we are calling linear. Okay, pair of linear equations in two variables. Here the variables are x and y. So x and y are the variables. That's why we are calling them as pair of linear equations. Equations. We are equating with something. That's why these are equations. Okay. When you draw the graph of any linear equation, the graph will be a straight line. Graph will be a straight line. In 9th class, you have drawn the graphs of linear equations, taking different solutions of the equation, plotting the points. So you got a straight line. So linear equation, graph of linear equation is a straight line. Now we got two linear equations. Both the equations are in two variables. We call them as pair of linear equations in two variables. If I draw the graph of these two equations, if I draw the graph of these two equations, I may get, both are straight lines. Straight lines can intersect. Straight lines can intersect. This is my first straight line. I'm denoting first straight line as L, second straight line as M. Chances are there that they both intersect at one particular point. So when you plot, you may get intersecting lines. Sometimes you may get parallel lines. Sometimes on plotting, you may get parallel lines. These two are parallel lines. There is one more option, one more chance, that is they may coincide one line falling on another line, one line falling on another line, both are having same points. Chances are there that both are having same points. So three cases arise when you draw the graph of linear equations. You will get three cases. The linear equations, the lines can be intersecting. They may intersect at one single point. They may not at all intersect. They can be parallel lines. Parallel lines will not meet each other. So no intersection. And they may intersect at infinitely many points. Infinitely many points. And those two lines may fall one on another, both having same points, both passing through same points, and these type of point lines are called coincident lines. Intersecting lines, parallel lines, coincident lines. Intersecting lines meet at one point, so they have unique solution. One single solution, one unique solution. Parallel lines will not meet each other. They don't have any solution, so no solution for parallel lines. Coincident lines meet at many points, so they have infinitely many solutions. Coincident lines will have infinitely many solutions. So please remember these points. So when you draw the graph of pair of linear equations, you may get intersecting lines or parallel lines or coincident lines. Both lines incident on one another. We may get coincident lines. Intersecting lines have unique or one solution. Unique solution. Parallel lines will not meet, so no solution. Coincident lines will have infinitely many solutions. Since intersecting lines give you solution consistently every time they give you solution, so intersecting lines are also called as consistent lines. Parallel lines will never give you solution, so they are inconsistent lines. So parallel lines are also called as inconsistent lines. Intersecting lines are consistent lines. Why? Because they consistently give solution. Coincident lines are also called as dependent lines. Now, coincident lines also give you solution, so they can also be called as consistent lines. Coincident lines भी solution देते, so coincidence lines को भी consistent बोल सकते. Now, what is the condition for intersecting lines, parallel lines, and coincident lines? The condition to get intersecting lines is A1 by A2 is not equal to B1 by B2. If this condition is satisfied, Then the lines are intersecting lines and they have unique solution. Condition for parallel lines. A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. If this condition is satisfied, the lines are parallel lines and they have no solution. They don't have solution. Why? Because parallel lines will never meet. Solution means wherever two lines meet, that is the solution. Now, condition for coincident lines is A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Please note down. The general form of pair of linear equations in two variables is a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. These are pair of linear equations in two variables. These linear equations, when you draw the graph, can be intersecting lines or parallel lines or coincident lines. Now let us see the condition for intersecting parallel and coincident lines. So let us write down the condition. First of all, if at all a1 by a2 is not equal to b1 by b2, then you will get intersecting lines. Intersecting lines. Intersecting lines are also called as consistent lines. Intersecting lines intersect at one point. Lines will intersect at one point. Both the lines will have one common point, one common solution. So intersecting lines have unique solution. Intersecting lines have unique solution. Okay. Now, the next condition is if A1 by A2 is equal to B1 by B2 and not equal to C1 by C2, then the lines are parallel lines. When you draw the graph of these lines, you will get parallel lines. Parallel lines will never meet, and the distance between the parallel lines is constant throughout. They are separated by constant distance. Example, we can take railway tracks. Railway tracks are parallel. Okay. So parallel lines will never meet. So parallel lines will not give any solution. So they don't have solution. These lines will not have any common point. They never meet. Okay. So parallel lines don't have any solution. Parallel lines are also called as inconsistent lines. They're also called as inconsistent lines. Why? Because they don't give solution. They are inconsistent. Intersecting lines always give solution. That's why they are consistent lines. The next condition is A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So if this condition is satisfied, you will get coincident lines. Coincident lines lie one above the other. Okay, they have same points. They have same points, same solutions. So they are called coincident lines. And they are also called as dependent lines. Every point is a solution, so they give infinitely many solutions. In this question is asking us to find whether the given system of equations have unique solution, no solution, or infinitely many solutions. So two pair of linear equations are given. Let us write them in standard form. That means, first of all, you should write given. What is given? First equation is 2x plus 3y is equal to 7. Second equation is 6x plus 5y is equal to 11. So we need to transpose the constants inside. We have to transpose them towards left hand side. So 2x plus 3y minus 7 is equal to 0, and the next one is 6x plus 5y minus 11 is equal to 0. Now write down the general form of pair of linear equations. What is general form? A1x plus b1y plus c1 is equal to 0. A2x plus b2y plus c2 is equal to 0. Now write down A1 value is 2. A1 is 2. B1 is 3. C1 minus 7. C1 is minus 7. A2 6. B2 5. C2 is equal to what? Minus 11. Now find out the value of A1 by A2. A1 by A2, A1 is 2, A2 is 6. 2 ones are 2 threes are. So A1 by A2 is 1 by 3. Now find what is B1 by B2. B1 is 3, B2 is 5. So here I came to know that A1 by A2 is not equal to B1 by B2. Not equal to what? B1 by B2. When A1 by A2 is not equal to B1 by B2, no need to find C1 by C2. Here itself we can conclude that The lines are what type of lines? The lines are intersecting. And intersecting lines have how many solutions? Intersecting lines have unique or one solution. Unique solution. So the given lines have unique solution. That's it. First of all, two linear equations are given. He is asking whether these equations have unique solution, no solution, or infinitely many solutions. First of all, write down given equations. What are the given equations? X minus 3y is equal to 3, 3x minus 9y is equal to 2. You have to transpose the constants towards left hand side. So what will you get? X minus 3y minus 3 is equal to 0. 3x minus 9y minus 2 is equal to 0. And you will write standard form. What is standard form? A1x plus b1y plus c1 is equal to 0. A2x plus b2y plus c2 is equal to 0. What is A1 value? A1 is 1. B1 minus 3. C1 minus 3. A2 3. B2 minus 9. C2 minus 2. Now check what is A1 by A2. A1 is 1. A2 is 3. What is B1 by B2? Minus 3 by minus 9. Minus minus cancel. 3 ones are 3 threes are. Again I am getting 1 by 3. What is C1 by C2? Minus 3 by minus 2. Both cancel. 3 by 2. So you can notice that A1 by A2 is 1 by 3. B1 by B2 is 1 by 3. C1 by C2 is 3 by 2. These two are equal. That means A1 by A2 equal to B1 by B2 is not equal to C1 by C2. So what is this condition? This condition says that the lines are parallel lines. Parallel lines are also called as inconsistent lines. Parallel lines will never meet, so they don't have any solution. So the answer is no solution. So these lines do not have any solution. In the next question, we have two linear equations. 2x plus y is equal to 5. 3x plus 2y is equal to 8. Okay, let us see let us check whether they have unique solution or no solution or infinitely many solutions. First of all, let us write the given equations. The given equations are 2x plus y is equal to 5, and the next equation is 3x plus 2y is equal to 8. In the first step, you will be taking these constants towards left hand side. When you transpose, sign will change. So you will get 2x plus y minus 5 is equal to 0. 3x plus 2y minus 8 is equal to 0. Now write down the standard form of the linear equation. A1x plus b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0. Now find out a1 value. b1 is 1. b1. Here you are having coefficient 1. So b1 will be 1. Can you tell what is c1? c1 is minus 5. c1 is minus 5. Compare both the equations. You compare and try to find a2. What is a2? a2 is 3. b2. b2 is 2. c2 is minus 8. Now what is a1 by a2? Check what is a1 by a2. What is b1 by b2? What is c1 by c2? a1 by a2 is 2 by 3. b1 by b2 is 1 by 2. c1 by c2 is minus 5 by minus 8. We notice that a1 by a2 and is not equal to b1 by b2, not equal. This is 2 by 3, this is 1 by 2. These two are not equal. Then immediately you can conclude that the lines are intersecting lines. The lines are intersecting lines. Intersecting lines are also called as consistent lines. And finally, write down they have a unique solution. They have a unique solution. Is that okay? So now these are the two equations. He is asking us to find how many solutions these two equations have, whether zero solution, unique solution, or infinitely many solutions. First of all, transpose 11 towards left hand side. Similarly, transpose 21 towards left hand side. We will get 6x plus 5y minus 11 is equal to 0. 9x plus 15 by 2y minus 21 is equal to 0. Now write down standard equation, standard form of linear equation. a1x b1y plus c1 is equal to 0. a2x b2y plus c2 is equal to 0. Now write down a1 value is 6. b1 value is 5. You can see c1 is minus 11. a2 value is 9. b2 value is 15 by 2. c2 is minus 21. Hope you understood this. Now check what is a1 by a2. a1 by a2 is equal to 6 by 9. 3 2s are, 3 3s are, 2 by 3 is the answer. b1 by b2, 5 by 15 by 2. This will become reciprocal. This denominator will become reciprocal. You will be getting 5 into 2 by 15. 5 how many times? 3 times. You will get 2 by 3. What is C1 by C2? C1 is minus 11. C2 is minus 21. Minus minus cancel. Answer is 11 by 21. Got it? You can notice that A1 by A2 is 2 by 3 and B1 by B2 is also 2 by 3. But C1 by C2 is 11 by 21. So we conclude that since a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. Once again, a1 by a2, b1 by b2 both are equal to 2 by 3, but c1 by c2 is not equal. So for this condition, we can say that the lines are parallel or inconsistent lines. So they have no solution or zero solution. Number of solutions is equal to 0. Write down here 0 solutions. That's it. Hope you understood this.
Sir,
In the next question, two equations are given. Minus 3x plus 4y is equal to 5. 9 by 2x minus 6y plus 15 by 2 is equal to 0. First of all, let us transpose this 5 to the other side. So minus 3x plus 4y minus 5 is equal to 0 is the first equation. 9 by 2x minus 6y plus 15 by 2 is equal to 0 is the second equation. If you want, you can write 9 by 2 as 4.5 and 15 by 2 as 7.5. If you want, you can write in decimals, or else just continue standard form. A1x plus b1y plus c1 is equal to 0 is the first equation. A2x plus b2y plus c2 is equal to 0 is the second equation. A1 is equal to minus 3, b1 is equal to 4, c1 is equal to minus 5, a2 9 by 2, b2 minus 6, c2 15 by 2. Whenever there is a minus sign, please take care of minus and do not forget minus. Okay, b2 is minus 6 here, a1 is minus 3. So after writing a1, b1, c1, a2, b2, c2, try to find out what is a1 by a2. A1 is minus 3, a2 is 9 by 2. So you will get minus 3 into 2 by 9. 3 3s are. So your answer is minus 2 by 3. What is b1 by b2? b1 by b2 is 4 by minus 6. 2 2s are, 2 3s are, you are getting minus 2 by 3. What is c1 by c2? c1 by c2 is minus 5 by 15 by 2. So you'll get minus 5 into 2 by 15. 5 3s are, again you are getting minus 2 by 3. So in all the three cases, the ratio of a1 by a2, b1 by b2, c1 by c2, all are equal. So what is the conclusion? The conclusion is a1 by a2 is equal to b1 by b2 is equal to c1 by c2, which means the lines are coincident or dependent. Coincident lines are also called dependent. Dependent lines, and they have infinitely many solutions. Okay.